Good afternoon and welcome. My name is Brad Antle. I am the chair of the NVTC Impact AI Summit and the executive chairman of OCS Networks. On behalf of my co-chairs, Charles Onstott III from SAIC and Tom Oteki from Virginia Tech, welcome to NVTC's Impact AI Summit. We're delighted that all of you have joined us for the fourth and final day. NVTC is our trade association representing the Capital Region's tech community. We unite, educate, and advocate for our members to advance a thriving ecosystem where we live and work. This region offers a unique set of artificial intelligence assets that has no other region in the world can match. Fortune 1000 companies, entrepreneurs and investors, proximity to and expertise in serving the federal government customer, a highly educated workforce, an unparalleled research infrastructure, and top academic talent. This ecosystem is dedicated to developing innovative AI solutions for both commercial and public sector customers. And that's what we're here today to discuss and explore. Before we invite our first speaker to the screen, I want to thank the companies and individuals who have made today's summit possible through their financial sponsorship and also their guidance and expertise as members of our event steering committee. Our platinum sponsor is Accenture. Gold sponsor, Ericsson Immigration Group. Keynote and panel sponsors, Digital Realty, Dovel Technologies, and SAIC. Silver sponsor, Fairfax County Economic Development Authority. Our program sponsor, George Mason University. Our PR marketing advisor, the Merit Group. Our public policy advisor, Hunt and Andrew Kurth. Our marketing agency advisor, O2KL, and our media partners, iHeartMedia, Scoop News Group, and Washington Technology. All of these sponsors have made their content today possible, have made our content possible today with their generous support and guidance. I also would like to thank NVTC's business partners and academic partners for their year-long support of NVTC. They are Booz Allen Hamilton, Center for Innovative Technology, Consumer Technology Association, Dell Tech, Dominion Energy, George Mason University, Inova, KPMG, Maximus, Microsoft, Nobless, Northrop Grumman, PenFed, Pillsbury, PNC Bank, SAIC, Venable, Verizon, and Virginia Tech. A quick reminder for anyone who wants to tweet from today's event, we'll be using the hashtag ImpactAI. We have a content-rich program today, at the conclusion of which we will have a Q&A session with our speakers that will cover all the subjects that were presented today. And we'll try our best to get through as many questions as we can in the time available. Please use the question button at the right of your screen to post your questions throughout the presentation. Please identify the speaker your question is for, and please don't wait until the end. Now let's get things started. To kick off our program, I'm delighted to introduce today's first keynote speaker, Kevin Parker. Kevin, no stranger to the Northern Virginia area, is currently the CEO and chairman of the board for HireVue, Inc. Prior to joining HireVue, was a co-founder and senior operating principal of Bridge Growth Partners and currently serves as a senior advisor to the firm. Kevin served as the chairman of the board of Salient CRGT and serves on the boards of Intermedia Inc., Plex Systems, Aptos Inc., and Cvent Inc. In addition, Kevin has served as the interim president and CEO of Polycom, chairman, president, and CEO of Dell Tech, and was a board member here at NVTC. We're excited to welcome Kevin back to NVTC. Please welcome Kevin Parker.
Thank you, Brad, and I'm delighted to be back here at NVTC here today. As Brad said, my name is Kevin Parker. I'm the CEO here at HireVue, and we're an organization based in Utah with international scope, really focused on democratizing hiring. And I'll share a little bit of that and what we're doing with artificial intelligence to improve the process. So maybe just a little bit about HireVue today. We're the leading provider of what we would refer to as on-demand video interviewing solutions, among other things. We interview millions of people every year for our customer. We interviewed almost 2 million hourly workers last year, about 1.2 million in campus recruiting, a very big area for us, at over 2,500 campuses around the world, and do a lot of work in retail. We've interviewed over the last 15 years more than 20 million people, and most of those interviews, almost all of them, take place after hours, and we do that on a global scale. We do that in 41 different languages, and there are over 750 customers around the world today that are using HireVue. But a little bit of the backstory, I think, about HireVue is important to understand how we got started and why we do what we do. And it's a typical American startup story. We were started by a college student here in Salt Lake City, Utah, who could not get a job. Our founder went to a small college and they didn't have big career fairs. And our founder actually thought that was a pretty unfair process, and time and distance and logistics were getting in the way. So we started on this mission to democratize hiring and remove barriers for people to get jobs, and using technology and primarily video to reach broader constituencies of talent, to allow candidates to interview more freely and allow employers to reach more potential employees. Really focus on changing the process in very distinct ways. As we've seen over the last several years, we've seen a really significant expansion in the number of companies and the number of customers that are using our solution. Many of our customers today are interviewing more than 1,000 people a day at multiple locations around the world. We've done over 21 million interviews. A lot of them take place on mobile devices. It's not unusual to see somebody, sitting in a car doing an interview on their mobile phone, because that's the time and place that's most convenient for them. So it's a very democratizing process and very significant expansion. But we realized several years ago that we were solving one problem. We were giving more people access, and we were inadvertently creating another problem. That is, who is going to watch all of these videos? Who's going to watch 1.2 million college students interviewing for jobs? And we realized that the source of that was really an opportunity for us to expand further and further our mission of democratizing hiring. So about 5 years ago, we realized that we could use technology to provide a different experience for candidates and employers and get away from the problem of actually watching all these video interviews. And HireVue really does something quite unique, and we've intersected two distinct disciplines to create a new solution in the marketplace. Data science, and we're obviously collecting a lot of information from candidates, mostly the words that they're using and the answers to questions, and IO psychology, and what are the questions we're asking, what does a good answer mean, and what does a less good answer mean for candidates. And so it's a unique intersection of those two ideas. We know from IO psychology, and that's a field of science that's been around for 100 years, there are things that work in interviewing better than others. And all the way over here on the left-hand side, we find the things that actually aren't correlated to success in the job. But these are things that can invade decision-making by companies and by individuals that actually have no bearing on the outcome of the job. Things like years of education, years of experience, conscientiousness. Those are things we tend to think of when we're recruiting people, but science tells us they're actually not correlated to success in the job. On the right-hand side, though, what are the things that are really correlated to success? Things like tests of general mental abilities, or GMA, combined with structured interviewing, meaning asking candidates really good questions that relate to the competencies of the job. Those are the things that really make a difference in hiring people. We've really taken that science and combined it with the ability to do a video interview. And a typical HireVue interview, and we've got a lot of different types of interviews. We're not looking for an archetype of a candidate. They're very specific to a job at a company. We can combine answers to video questions, game-based challenges that are really focused on cognitive abilities, and we even have coding challenges. All of those can take place in the context of a 20 or 30-minute video interview and get a really strong sense of the candidate based on science and based on what we know it takes to be a success in a job. So we talk about bias today, and bias in hiring comes from a lot of different sources. And we're going to talk a little bit about how we mitigate for bias using artificial intelligence. But bias today in hiring, and we've seen it in a lot of different areas. There's a lot of varieties to it. Certainly conscious bias, those things that we as decision makers or evaluators consciously reject candidates for a variety of reasons that have nothing to do with the job. There's unconscious bias too, things that we're not aware of in our own decision making that invade the process in unique ways. There's also a whole category of things that we refer to as policy bias. You need an advanced degree, you need 10 years of experience, you need to have worked at and gone to certain colleges. That's actually policy bias that rejects a lot of candidates that are actually very qualified for the job, but we put these hurdles in place just because we think they work. And the reality is that they don't add any value to the interviewing process. One great example of a company that tried to do really well and I think used artificial intelligence using resumes in a very unique way is Amazon. And this actually occurred a few years back. But Amazon did a great sort of inventive way of thinking about resumes, and they actually removed any gender and age and race information from candidates' applications and resumes and started screening them. And they were trying to look for candidates that would fit well with Amazon. The reality is that while they removed all those things, other things crept in. It turned out that they were biasing towards men as opposed to women, not because they were more successful, because men's resumes actually contained data that didn't tell they were men, but actually correlated to the men that they had hired more closely, whether that was their athletic experience, clubs they joined in college, whether they had an advanced degree. And so as they let this algorithm run, it actually created bias in the process that they were trying to remove by removing all the gender information. I think it's a great example of an effort that was well conceived, but the data actually pushed them in a different direction. As we think about our science, and we're doing something quite different, and as we think about assessments in our science framework, we're really focused on a few key things. One is, as we look at a candidate, do they have the ability to work with people? What is their personality type? What's their work style? Do they have the ability to work with information? This can be everything from working memory to fluid IQ to visual spatial relationships and a variety of things that are important. We're looking at their work style and personality as well, and how do they handle customer service components? How do they handle correspondence? Are they empathetic? And then we can assess for technical skills using coding challenges I mentioned a moment ago. So we're really looking at the fundamental building blocks of success in a job, not what their resume says, not what their LinkedIn profile says, but them as an individual, and how do they match up against the characteristics we're looking for or an employer is looking for in a particular job. We have a very modular approach to that, and we can assess for a variety of things, everything from compassion to emotional intelligence, cognitive ability, conscientiousness, extroversion. It's sort of a partial list of the components, and each of these is a modularized assessment. Everything that's in yellow here is a game-based assessment, and we can do a lot with gaming and gameplay. Everything in blue is in analyzing the candidate's answer to a structured interview question. Tell me about a time when you did the following. Tell me about your team orientation, a variety of things. We can mix and match those capabilities to create job-specific assessments for an individual company. As I said earlier, there's no archetype we're looking for, but each of these is validated. Each of these has been checked for adverse impact against various demographic groups, age-related, gender-related, race-related as well. And so we can build that together and really look at a candidate from a different perspective using artificial intelligence to gather and analyze a lot of information. So as we think about assessments today, all of that is based on a very secure infrastructure, and it's very unique to individual companies. And we do a lot of work to really mitigate any bias that we see in that process. And I want to talk about that just for a minute in terms of how we think about how assessments work. The fundamental process here is to take candidates and transfer from a traditional first in, first out process to a best in, first out. Right at that initial interview, right at the top of the hiring funnel, we can provide an assessment and tell recruiters, exactly who is going to be the best fit for their job and to focus their time and attention on that. It can accelerate the process both for the people that are doing the recruiting and the candidates, from both the candidates that are going to be moved on generally to an in-person interview later in the process, or get a polite no, thank you, but you're not the right fit for this job at this time at this company. So really change the dynamics of the process in a very exciting way. Obviously, we spent a lot of time thinking about bias in the interviewing process, and there's a lot that's been written about bias in artificial intelligence algorithms. We're very fortunate in the hiring world that we actually have a well-established legal framework that we operate within, both here in the US and abroad and overseas as well. And a lot of thought has been going into just hiring in general and assessments in general, and we build all of our assessments on that strong legal foundation. A little bit about how we do that. And so we think about the inputs that we're collecting, and it can be from a variety of sources. It can be from that gameplay, but in the video interview, what we're really analyzing is the candidate's spoken answer to the question. If I tell you in a very simple example, I'm going to ask you about team orientation, and this is incredibly simplistic, but bear with me, that candidates that are team oriented tend to use the word we more than they use the word I. We can use natural language processing, transfer their spoken word into text, analyze that text, and understand through a machine learning algorithm the candidate's output and then the candidate's ranking relative to others that have taken that interview. So a lot of thought goes into that. And what we've done over time is built algorithms that replicate what a trained evaluator would do. We obviously have a lot of data, a lot of interviews we've done. We have a lot of trained evaluators. And so we've created algorithms that can mimic, if you will, what a trained evaluator would do with that very same interview around those competencies we talked about a moment ago. So we can rank those candidates and make sure that the recruiters are really focused on the best candidates for that particular score and for that particular job. All of it is based on a job analysis that our IO psychology team will do and understand the attributes of success, but help recruiters identify the best people in the process in as fair and as consistent a way as possible. When we think about the assessment input data, we're actually, as I said earlier, talking about the spoken word. We're not analyzing the video. There's people ask, should I be concerned about my background? This isn't a screen test. We're actually looking for people. Companies are trying to reach as many candidates as we possibly can. And so it's that input that's really important to us. We're not, and we make a lot of effort to not include any information that would give us any context of who that candidate is as an individual. They've applied to a company, but we're not looking at anything associated with age, race, gender, looks, religion, sexual orientation, or the video background. None of that is important. None of that is analyzed. We're looking at the natural language processing text of the spoken answer that the candidate has given. Even so, you have to be very, very careful. And there can be bias that can, much like the Amazon example, bias that can creep into models. And we have a lot of work that goes into every model before that we put anything into production, both on our end and together with our customer. I'll give an example here. We know, for example, and I'll share an example. We know that, for example, that if we're looking at a particular aspect of an interview, we know from a lot of data that men tend to talk more quickly in interviews than women do. That can be picked up by the model as something that is somehow indicative of success. And when we look here, we're looking at a pass rate and a male-female pass rate of a particular component that would not meet the 4/5 rule as promulgated by the EEOC. And so this is not a good model. And so we wouldn't use this information. When we know some of this gender-specific information or race or age-specific information, we can actually mitigate that model. We can remove that feature set. We can remove that data so that we're not evaluating speed of answer as part of the process and really try and make it as neutral as we possibly can. And we're very fortunate that we have a lot of very smart data scientists that can look at all of this information and find anything that's correlated to undesirable outcomes, race, age, gender, excuse me, and remove that from the model, and at the same time, emphasize those things that are correlated to success, team orientation, empathy, and a variety of things like that. As a result of that, we can actually close the gap and wind up with models that have very mitigated results and still correlate very, very high to job outcome. And that's a lot of work that we can do because we've got a lot of data around individuals and candidates that really level the playing field and provide a consistent scorecard that meets all the legal requirements and mitigates most of, if not all of, the value that we see coming from undesirable attributes and undesirable outcomes and adverse impact to candidates and to groups of candidates as well. So really interesting part of the process. We can collect all of this information and do a lot of work to make sure that we've got very strong models that are very highly correlated to outcome in a particular attribute and mitigate anything that points to any undesirable outcomes or adverse impacts associated with individual groups of people. The process that we use also is very iterative, and we put models in place. They never are unsupervised, to use the term of art from data science, but we collect all the information, we analyze it, we do a substantial amount of checking for bias and adverse impact. We'll publish the model, and on a periodic basis with our customers, come back and reevaluate the model and come back and make sure that we're still getting very good results for their candidates and their groups of people and their objectives in terms of hiring great talent. So very iterative process, very distinctive process, and one that we can replicate for many, many customers. We have over 1,000 models in production today. Each one of them is unique to that particular job and that particular company. And we've had more than 1.5 million people take our assessments over time. And so we're very confident in the results, and they stand scrutiny at any point in time. So very proud of the results from that perspective. As we think about the future and really start to think about how AI is focused, particularly AI that interacts with humans, there's a lot of work going on both publicly and behind the scenes around audits and explainability. And this is really the next frontier from our perspective in terms of how AI works and how we're going to use AI going forward. A lot has been written about this, and you know, if you read, and there's a lot published, and a lot of research about the algorithms and how they can be biased. And the reality is, left to their own, algorithms can develop undesirable attributes. And there's a lot of work that needs to go into making sure that they're fair and consistent. We put a lot of thought and effort into that, and I think we're a bit of a pioneer in terms of how we think about our responsibility, particularly with hiring and how we're impacting individuals' lives around transparency and auditing. First of all, we have published a great deal and have a very robust AI ethics set of principles. We've published that. We've got an expert advisory board of outsiders that are constantly looking at what we're doing and really starting to think about our responsibility and make sure that we've got a very strong set of ethics and very strong set of principles that we adhere to and really take the responsibility about mitigating bias as best we possibly can. We do a lot of work around explainability. We have, I think, been a pioneer in the field of auditing. Now, unlike financial audits, which have a very well-established track record, audits associated with algorithms are a very new field. And so we're working in a lot of different dimensions at the same time with respect to audits. We've done an audit from an IO psychology perspective and had outsiders, and we just published this a month ago, had outsiders in the field, the expert field of IO psychology, come and look at our information, look at how we were assessing people against established standards for IO psychology. And we've been very, very happy with the results and very successful, I think, in terms of meeting those very high standards. We also completed an artificial intelligence audit earlier this year. We had Kathy O'Neill, who's probably one of the experts in the field, come in and with no restrictions on our part, audit our algorithms and audit what we do. And I think we're very proud of those results as well. We do a lot of work, and as the quote says, we ensure that every assessment complies with the major legal fairness doctrines on a global basis, and we're very proud of those results as well. We've published a lot of white papers in peer-reviewed journals as well, and really starting to think about transparency associated with auditing and with algorithms in general, and want to be seen as a leader in that area. As I said, algorithmic auditing is a new field, and a quote from Kathy O'Neill, I won't read it here, but we are very fortunate, as I said earlier, that we operate under a legal framework where there is a very well-established framework for assessing candidates and understanding adverse impact and a sense of fairness and what that means in terms of employment. And so we're very focused on that as well. We do a variety of third-party audits. I won't go through all of this, but a lot of independent review of our work. All of our customers are also very focused on that and work together with us around making sure that we have a very strong stance with regard to fairness and outcomes for all of their candidates as well. So that's a little bit about HireVue and how we think about audits and how we think about bias in general. I'm very interested in any follow-up. If people would like to reach out and learn more, we'd be delighted to do that as well. But thank you for having me here today.
Thank you, Kevin. That was fantastic. Now I'd like to introduce our panel on infusing our AI work with ethical awareness. Our first panelist is Ronald D. Fricker, Jr., who's the Interim Dean of the Virginia Tech College of Science and a professor of statistics. Prior to Virginia Tech, he was a faculty member in the Operations Research Department of the Naval Postgraduate School, and before that, a senior statistician at the RAND Corporation and the associate director of the RAND National Security Research Division. Ron Kenett is the chairman of the KPA Group, Israel chairman of the Data Science Society of AEAI, senior research fellow at the Samuel Neiman Institute, Technion, Haifa, Israel, and research professor at the University of Turin, Italy. He is an applied statistician combining expertise in academic, consulting, and business domains. Yevgeniy Sirotin is a senior scientist manager at SAIC's Defense and Civilian Customer Group, specifically supporting the Department of Homeland Security Science and Technology Directorate. As the principal investigator at the Maryland Test Facility. And our moderator is Dr. Rod Fontecilla. Rod is the Senior Vice President and Chief Innovation Officer and Chief Data Scientist at Dovel Technologies. He directs strategic research and development efforts, advances initiatives to expand corporate technical competencies and capabilities, and fosters the development of innovative solutions for current and prospective customers of Dovel. Rod, over to you.
Well, welcome to today's panel. The topic today is bias in AI. And let me just put this thing in context. So there is tons of data out there, right? I mean, 90% of the data that has been created is being created over the past 2 years. Only 1%, they say, of the data has been analyzed. And as we know, AI is the way to make sense of all the data, process the information, transform these raw data into really actionable insights. So AI is becoming more powerful than ever and more important in everything we do. So ensuring that these AI systems are used appropriately is one of the hardest challenges that we have today. And the fact that we are using it everywhere, search engines, online marketplaces, hiring applicants in the HR side, identifying cancer, and by looking at x-rays. So this is becoming the complexity is increasing. And therefore, identifying biases and eliminating that bias is critical. So my first question to the panelists is, when you look at gender, race, ethnicity, economic factors, what do you think are the sources of biases with respect to AI? And if you could, in each one of your areas, give us some examples of how things could go wrong. You go, either one. Ron Kenett, let's start with you.
Okay. So So the question is not obvious, right? It's not like there is a simple answer. And I would like to concentrate on bias induced by the training set. So the approach in AI is driven by by fitting the shirt to the data. We are not considering how the data was generated. We are fitting models to the data. And if the data that we use to train the model has some structure, for example, there is an inherent imbalance in how this training data is set up, we're going to get algorithms, predictive models, which will reflect that. So one preemptive effort is to say something about the training set in terms of bias. And that requires some not obvious analysis. The bias could be multivariate, could be complex. The structure in the data that I'm thinking about might not show up in an easy descriptive histogram-based analysis, and this becomes even more complex when you deal with time series. If your data is over time, you could have all sorts of funny things happening that will affect your models. So so I probably took already too long. I will think about examples. There are many examples, but I would rather hear the others before I go into examples.
All right. Yevgeniy.
So I could follow up with that. Ron sort of addressed the data set part and algorithm training, and I think those are important areas to focus on. And I wanted to sort of also point out that, these days, what we mean by AI algorithms are things that really mimic human intelligence, down to the fact that they're now, using convolutional neural nets that seek to simulate human neurons as well. And these systems, although they're becoming more and more complex, they take less and less time these days to develop. So this AI training has become, a pipeline. It's a commodity. And some companies, in fact, churn out new algorithm versions monthly or even quarterly. However, balanced and carefully curated training data for these systems are important, but these training data are constantly being supplemented and changed, and the algorithm architectures are constantly changing. So what do we do to ensure that these systems that we're churning out are bias-free? And the problem that I want to focus on in my response is the fact that no AI developer really can reliably predict how the system will work on operational data from a particular use case, partly because oftentimes you don't have access to that data, to how your customer might be using that system, to what the conditions on the ground are. So you almost have to, in order to know whether or not a newly trained algorithm performs well, is through testing and careful monitoring to catch bias issues quickly when they occur. And there are some significant recent efforts, I think there's a lot of work on this, to standardize how this is done for AI more broadly. And this is being done in the AI ISO standards processes. For example, ISO TR 23027, it's currently in draft. It seeks to create a general standard definition of bias and the kind of bias that could be expressed by an AI system. And we need to know that in order to be able to measure it, or to create a standard around how to measure it. And my group had just submitted a new draft standard, ISO 19795-10, on testing specifically in my field, biometrics and identity systems for differences in performance, or what we call in this panel bias, across demographic groups. And these efforts can really help us catch these biases in AI systems as they're built.
Good. Ron Fricker. I hope you heard the. I know there is a possible storm on your side. So, but were you able to get the first question?
I missed it, Rod. But how about if I just catch up as we go along? It is storming nicely here.
Yeah, and essentially is when you look at biases with respect to AI within your field, Ron. What do you think? What things can go wrong? And so tell us a little bit. I mean, some examples perhaps that you have experienced in your field of academia as well.
Well, so I'm a classical statistician, so I really think about things from that perspective, and that involves models, but probably not typically the algorithms the complicated algorithms in AI. One of the challenges there, of course, is the complexity of those algorithms. Even simple models can go wrong and can have biases. And as a classical statistician, we think about those things, right? We think about the output not reflecting sort of truth, whatever that may be. And that's what Yevgeniy was really describing there in an AI sense. So it can go wrong in any number of ways. I think the key is what he was saying, though, which is testing. It's really rigorous, careful testing. In my experience in the DoD world, AI is really getting to be more and more prevalent. And that idea of this really complex, careful testing of AI and its outputs to make sure it's doing what you want it to do, whatever that is, right? Bias is just the algorithm not doing what you want it to do on some space, is the key part of it.
Good. So we're touching this that the algorithms really are learning from the data, particularly the training data that we use to create these algorithms. So very similar how children learn from observing, behavior, right? So how much intelligence do you think is in the algorithms itself that we're creating to rectify those biases? Do you think that's possible?
So I will address the question, but I would like to follow up a little bit on what was said. So Yevgeniy mentioned the need of ongoing monitoring. So that also addresses your question. The context I would like to bring in is the pharmaceutical industry. The pharmaceutical industry has traditionally gone through steps. You develop a product, you develop what is called CMC, which is how you're going to produce it. You have a process validation phase, and then you produce the product, the drug product, and you deliver it. What the FDA has launched quite a few years ago is an approach which is the label of it is the new process validation guideline, where you really have continuous process validation. There is no such thing as here it is, you don't have to test it anymore. You have to continuously test the product. So I think what Yevgeniy mentions is that when you deploy in MLOps, when you deploy anything, since the whole thing is based on the data and there is some dynamics in the data, you also need to deploy a monitoring scheme. In the pharmaceutical industry, it's called a strategic process control approach. So you need some monitoring. This is relatively new as a concept. People do A/B testing, and the people who do A/B testing, we've worked with several companies. They do A/B testing. They are not tracking the users' profiles. They are tracking the outcomes. So if the user profiles change, they have the outcomes, but they don't realize what is really behind it. So in introducing proper monitoring, if we go back to the basics of monitoring, which is sure and statistical process control, we're talking about 1920, right? this is probably needed, and I think it's yet to be implemented. People would like to see, going back to your question, a one-shot deal. You know, we have an algorithm, we test it, we deploy it, and we tick the box. You know, we are done. This probably is inherently bias-prone because you don't really know what's going to happen. So the things can turn out to be very problematic. So the approach that the comp sci people who do these things, mostly computer science, should somehow include is something that statisticians have done for many years, which is statistical process control, which addresses variability, uncertainty, and raising the flag when something is happening. So you need some convergence, whether it happens or not. I would rather, my biased view is that it's not happening.
Yevgeniy, what do you think? I mean, you're saying testing is a monitoring as well, critical.
Testing. So testing can be perceived as a quality inspection phase. You know, we test and then we label the product green or red. But testing is a data generation effort. So it can be considered as a testing engineering activity whose goal is to gather data, analyze data, produce insights from the data. A lot of people who wear the testing hat see themselves, that's my biased understanding, they see themselves as inspectors. They don't see themselves, I think Yevgeniy is probably the outlier because I know he's doing other things, but many test organizations are wearing the inspector hat. You know, they have ATPs, they go through these 2050 tests, they check them, here it is. The configuration control is now frozen, here is the product.
Right, and it could be a combination, the monitoring with the testing. Yevgeniy, what do you think?
Yeah, no, I think you know, these systems, the AI systems, are becoming so complex that the way they arrive at answers, you can't really understand them. Even the creators don't really understand what all the layers of a convolutional neural network are doing. And so, as with human intelligence, you mentioned the parallel as well. It's important to test these systems to help develop intuitions about their behavior so that we have an understanding. And to ensure that they meet these quality thresholds on delivery. But you don't just test human intelligence in the classroom. You have to test them during the job, during job performance. So that means that some of the responsibility for the testing actually is pushed onto the customer and the user of the system. It's not just the creator, because that customer now has access to the live images or whatever other data that system is operating on. It's their responsibility too. And I'll say this, you asked for an example earlier, and I think I have a great example to share with the group for this exact issue that you need this ongoing testing. So, you know, we're all aware that within this last year, we had the COVID national emergency in the US, and that has resulted in folks taking a lot of precautions in the travel environment. That's an environment where, you know, I've done a little bit of work on, specifically around face recognition. And the impact was that a lot of individuals are now wearing face masks. And if you may have noticed that your iPhone doesn't do so well recognizing your face when you've got a face mask on. It won't open for you. However, there are systems that will, say that they do work with face masks. And so we ran a test over this last year looking at how face recognition works with and without face masks. And traditionally, we've seen, over the last few years, face recognition performance has gotten so good that when we throw diverse groups of people, folks that self-identify as white in the US, folks that self-identify as African American in the US, folks that self-identify as Asian, these systems generally work at near 100% for all the groups in use cases that are representative of how they're used in the operational environment. However, we tested with face masks and we found that there was now we sort of unmasked the difference. And we found that after, folks started using face masks, the performance became, less equal. So these systems actually worked really well for folks that self-identified as Asian, but folks that self-identified as African American, another minority group, the systems underperformed. And so it raises the issue of, like, even if you've tested the system without face masks first, if now conditions on the ground have changed, and we know they've changed a lot over the last year, right, you need to test again. So it reinforces this notion of you need ongoing testing as part of your AI deployment.
That's great. And you brought a really interesting point, which is, these AI systems are becoming extremely complex. And the ability for us to understand what these AI systems are really doing and how are they coming to the outcome is critical. So together with biases, there is this concept of fairness, and also people are talking about explainable AI. How do you see these concepts developing in when we use AI and vis-a-vis bias in the different situations?
So you can add to the list adversarial AI.
That too.
So yeah, bias can be perceived, as something we don't want, but it can also be perceived as something we induce. So the coin has two sides. It has also implications. The worst fear you have with these highly computerized cars is that someone takes over your car and and drives you to a place where you don't want to go, right? So I keep having this idea when I enter my car. Who knows? Someone can take my car and do whatever they want with it, right? I don't think it's that difficult. So the fairness, the bias is relative. It depends on how you evaluate what is going on. The explainable part, I also find here an opportunity of convergence between statisticians and computer scientists. What computer scientists are referring to in terms of explainable AI, which relates to variable importance, Shapley values, is so minimal in terms of explanation. It's pathetic for me. That's not explainable. To list the variables by importance that you derive through Sobol indices or whatever you do is so minimalistic in terms of explanation. It doesn't carry any causality. It doesn't really address any diagnostic capabilities. Explainable, you would say, oh, if something happens, I would like to know why. So they map the picture and they say this has been identified as X because of this red dot on the top. That's maybe for images adequate, but in many applications, it's very far from being adequate. So I think the wall, the explainable AI wall has been hit. I think there are lots of things that need to be done. There is an issue, for example, of causality that needs to be addressed. If you want to really explain something, you would want people to know, why has this caused, what has caused the situation we are facing. So I think you're opening a lot of questions here, and I'm not sure there are, at this point in time, good answers.
That's okay. Ron Fricker, And I hope you got the question. I mean, and again, we know that you are in the middle of a storm, so you're going back and forth. But we're talking about biases and also the concept of fairness and explainable AI. How do you see these concepts playing a role as we look into the complexity of AI systems?
Well, once again, I missed the question, so sorry about that. But could I go back actually to what I heard Ron and Yevgeniy talk about
oh,
earlier?
Absolutely. Yeah.
And this was the point of sort of process monitoring and also the COVID connection, because I did want to make a point there, which was the process monitoring, as Ron probably said when I wasn't here, is a commonly used tool. It's been around for 100 years. And it's used in many other fields that I do think applies in this case. And I was thinking of COVID as an example of that with the vaccines, where we are right now monitoring vaccines. If you think of the vaccine as an algorithm of some sort, right, for treating people, we are monitoring those outcomes right now in real time to make sure those vaccines are safe for people. I think it's an analogous situation to AI. It's just that it's not a computer algorithm. It's a biological algorithm, if you will. So I do think there's lots of examples of that. And it's been used for a long time in manufacturing industries. I think it's just got to sort of catch on in the AI world where we do use these tools regularly to monitor how AI is performing. I'd make one other point, which is to connect testing to the defense world again, where there's this notion in the defense world of what they call developmental testing and operational testing. And Yevgeniy was kind of talking about that. Developmental testing is kind of this testing you do in the classroom, right? Or you do in the shop, or you do in the lab on the bench where it's in sort of perfect conditions. And then there's the operational testing, and that's where you take it out into the real world with real users, with real data, and you try to see how it goes. And you want to do those things first, I think, as you guys were talking about, first, but then you get onto the monitoring piece of it. So I hope I'm not dragging us backwards in this conversation. Again, I apologize for my weather.
No. This is great. I think it addresses a lot of the points that we're bringing together, which these AI systems are extremely complex. We rely on the data to see how well these they're going to behave, and whether it's the monitoring, the testing, and the testing in different areas, or also waiting for the operational side. I mean, and that's a different ball game than when you're testing in the classroom or in the lab. So what can we do to really eliminate that bias and making sure that whatever results we're getting out of these AI complex systems are meaningful and are actionable insights? So,
and I think to answer your question a little bit, the second question is the complexity, right? Again, classical statistician, I think in sort of simple models when you compare it to some of these very complex AI systems. And I think by their very definition, they're complex and therefore they're really not interpretable, right? They're kind of black box systems typically. That just makes it hard to disentangle what's going on, but that only makes the testing on the outside, the back end, more important, in my opinion, because that's the only way you can really figure out what that black box is doing.
Absolutely. Yevgeniy, how you say the explainable AI, you touched that point before, and the fairness side. How do you view those ones vis-a-vis the bias?
Rod, thank you for that. I'm going to take a slightly different take on explainable AI and fairness. And I'm going to say that, well, first of all, fairness is very difficult to define. So as social beings, we sort of know it when we see it, and we know it when we don't see it. But fairness doesn't really lend itself to like a rigid mathematical formulation. Sort of not like statistical bias, certainly. And an AI, I'll make this point, AI that may be perfectly fair in one situation may be unfair in another situation and other use cases. Like, for example, if you look at image labeling, it may be more problematic than other use cases of similar AI, say comparing images of people to make an identity decision. And I think we need to get better as technologists at explaining how AI works in these different situations. Like, what are the differences between AIs that assign labels based on data and differences in AIs that, say, measure distances between data points? And I think we need to get better at explaining this. And so we could set reasonable expectations for AI systems so that we know when these are likely to fail, like for example, in estimating gender from an image of a face, or even worse, predicting criminality from a face, or when the ability of an AI system might actually be, really in excess of any reasonable human performance, like for example, face identifications. Even though people, do have a face identification system, it's, at least currently, far inferior to what we can do with AI technology. So my point here is that fairness depends on how the technology is being used, and we need to get better at explaining how failures can lead to unfair situations in some use cases. And I think we do that through outreach and education. And so the folks that are shopping for an AI system or thinking of implementing an AI system can make a more informed decision. Do they understand how it works well enough to understand whether or not it's going to give them acceptable performance in their use case? And what will be the ramification of the errors that the system might make on their users?
Can I follow up on this, Rod?
Yeah, absolutely, Ron. Yep.
So I'm still on this idea of convergence between classical statistics and in the 80s, well, I was working at Bell Labs in the 80s. AT&T was, developing the products, producing the products, installing the products, maintaining the products. And I had an AT&T employee tag. 1 million people had that tag. So it was quite a unique environment. In that environment, the operational follow-up on the systems was highly developed. It was an essential element. And AT&T Bell Labs developed a whole approach to survey, to field data analysis. There's a paper, a very good paper by Bernie Saperstein in 1981, I think, Bell Systems Technical Journal. How is Bell Labs organizing all the data coming from all these systems around with failures in components, failures in systems? How is this documented? How is this analyzed? So the needs are now different, but that type of infrastructure could be could give ideas on how it could be implemented in the context that Yevgeniy is talking about. So things have changed, but things should not be reinvented too. So in terms of collecting data from operations, there has been quite a lot of experience out there that can be leveraged. And my bias on computer science people is that they tend to reinvent things. So I'm always trying to bring out some references. Take a look. Spend half an hour. I'm not saying spend 3 days, but spend half an hour so you don't feel that you are solving the world's problems for the first time.
And so if I push back a little bit on my fellow statisticians here in the panel, so machine learning models, AI, are really made to make accurate predictions as possible. When you look at statistical models, you're trying to kind of look for inference about the relationship between the variables, right? So are these two separate things? You guys are trying to bring the statisticians kind of rather than the AI developers and building the AI complex systems. How do you see that? And how do you see the development of AI complex systems and also the bias? Because with just looking at the inference of variables, within statistical systems, you're not going to identify necessarily bias, right? How do you see that happen? Working out. Anyone in the panel, by the way.
Well, I guess I would start with a nod to the computer scientists, right? Because they do build complicated models, solve complicated problems that I couldn't solve with a lot of my traditional statistical tools. And sometimes it is this philosophical difference you're describing, prediction versus sort of explanation in some sense, or inference. But statisticians do prediction too. But computer scientists have tackled problems that my regression model would never solve. So I give them credit for that for sure. I think another positive part of this, sort of the bias, fairness, however you want to think about the problem, is the notion that was pointed out to me recently that human beings are also algorithms that are black boxes, and we have our biases. The nice thing about the computer algorithm is it's repeatable, and therefore you can test it carefully, back to testing, and identify those biases that are probably a lot harder, to identify in human beings. When you think about, an algorithm for sentencing versus a judge, right? You can really test that algorithm very carefully. It's harder to test the judge.
I'll make a couple of points as a not, so by training I'm not a statistician, nor am I a computer scientist by training, so I could play the role of maybe Switzerland. I am a trained experimentalist, and I am a neuroscientist by training. So I'll say this: I think that you're right, Rod. Sometimes explaining why, in the causal relationships between things is sort of outside of, I think, the current goals of AI systems. However, maybe with explainable AI, that's going to change a little bit. But I would say that the fact of the matter is the kind of capabilities that we're gaining through the use of deep convolutional neural nets and this kind of artificial intelligence that's leveraging these is really tremendous, and they're really in many ways exceeding human perceptual systems, and they're certainly exceeding the capabilities of individual people. They don't need rest, they don't need sleep, they could be trained in the wink of an eye. It doesn't take us 18 years of school before we can send them off to do their job. So we can't sing praises enough to the folks that develop these systems and that have revolutionized, I think, what we can do with them. However, that does not, now the panel is we're talking about, given the fact that they are getting all deployed, what do AI developers need to also pay attention to make sure that their tools, wonderful capabilities that they're building, integrate well in our society and don't cause, every time you integrate a new technology, you're going to solve a lot of old problems, but you might cause a few new ones. And I think that, in my opinion, it's, I don't want to, I do a lot of testing, right? And I don't want to in any way to say, hey, your product is bad, or that it's, folks have compared face recognition to plutonium and said it's radioactive, and that we should ban it. I think there are specific uses of the technology that are going to be really a labor saving and a security advantage, and we should definitely do those. But I think, as this panel has been saying, because the technology is so complex, we do need to test, we do need to scrutinize the performance to make sure that we're not, that technologies, as they become more prominent, work well for everyone.
Excellent. And Ron Frigger, Ron,
so
go ahead.
Tom Peters has the concept of a flying wheel. In getting the flying wheel to push the organization forward, you have some steps. The first step, you need the right people in the right spot on the bus. Who is the team? There's the whole approach, and the computerization is coming at the end. If you computerize things at the beginning, then I think Yevgeniy is putting forward an understatement. Then you could have big problems. I've seen companies go under. They used to work fine, everything was fine. They installed an ERP system. It was done without any proper preparation, and it was catastrophic. So what these algorithms that don't sleep can do, they can also create problems big time. And there is a sense of urgency that should be maybe pushed forward. You know, this is not nice to have. This is something that really needs to be considered. And we don't really have the good answers for that. So people should show some humility in how they approach these problems. You know, it's not like here is the answer. You should show some open mind to how things are done, and you know the problems pick up from nowhere. You know, you suddenly are in a problematic situation. There was no early warning, and it was not anticipated. So you know there are differences between risks and uncertainties. You know, risks are things that happened. You can assess how often they happened. You can say something about them. Uncertainties are related to knowledge. You don't have the knowledge. So how do you manage this combination of situations? And you need to be close to the business. You need to have a hands-on approach. You need to be listening. You need to have all your antennas. You know, so that's an organizational issue. These algorithms that you mentioned, Rod, AI, ML, whatever, need also to have an organizational shell to ensure that we are getting what we want and that we are not getting what we don't want. And that's not obvious. That's not obvious. Deming was referring to a director of statistical methods, referring to the CEO. That's the role of the chief data scientist. He should be working for the CEO on data science and not on related and not data science related topics. He should have a whole perspective of the organization, because otherwise, if he is only pushing out deploying algorithms, that seems to me very risky.
That's great, Ron. And you're touching a really interesting one for another panel, which will be, what's the role of the data scientist in an organization? So that will be great. But coming back to our topic, and I think it's something that the three of you have touched, and we have a few minutes, about 8 minutes left. And you mentioned this, the three of you, like any tool can be good or bad, right? I mean, a knife could be used to, chop salad or attack someone. It just depends ultimately on the person behind it, right? And I think Ron Fricker mentioned this a minute ago. I mean, human beings by nature, right? We are biased. I mean, and the data that we're using for building these algorithms have been created by humans. And so to tackle kind of AI bias is critical, like these data science teams, and perhaps going back to what Ron Kenett was saying, need to be educated, right, about, how do we collect this data, right? This data collection to ensure that we are not feeding these AI algorithms with biased data sets that ultimately are going to create AI systems that are really going to be biased. So you have these three things. You have is the data, the algorithm, or the humans building all this. So what are your thoughts? Let's start with Ron Fricker on this one.
Well, I think you laid it out perfectly there, Rod. So I was just going to say, back to your point about computer science and statisticians, I think we have similar workflows, if you will, right? We have to start with the data, as you just described, right? We build an algorithm, whatever that might be, whether it's a neural net or a regression, and then there's output from that. And I think all three steps of that, sort of Ron Kennett's point, is a process by which you have to monitor, you have to keep track of that, right? And at each step you can go wrong. You can feed a good algorithm bad data, or you can feed bad data to a good algorithm, So you have to make sure each one of those steps is done rigorously. And as a statistician, I always think about that. I'm in the process right now of doing a study of seroprevalence, right? How many people, I'm trying to estimate in a population, how many people have had COVID. And we've collected data, and we have data that is not representative of the general population. So I have to think about that before I feed it into my algorithm, which is going to be some simple statistics. But think about that at each step and then look at the output and try to make sure that output isn't biased or that it's fair. So I do think all that applies. And it's as you said, it's a knife. It can be used for good or for evil. If it's good, you're being very careful about your use of it.
Good. Yevgeniy?
So, I think computer scientists working on AI should also educate themselves in human cognitive psychology. And I'm biased on this because I am a neuroscientist by trade, and I'm now working in the field of AI testing. So I like to say that I sort of play a role of a sort of Dr. Freud for AI. I put it on the couch and I say, how does this make you feel, right? And as we design systems that mimic human cognition, we need to be careful to recognize our own failings as human beings. For example, I'll give you a concrete one. People categorize faces that they are unfamiliar with based on race and gender. And computer scientists working on face recognition never question, because of this, when face recognition algorithms do the same. So their own human perceptual biases make it into the AI. And it takes a lot of work even to point out that this could lead to unfair outcomes in some situations. And I think that one thing Ron pointed out is these algorithms that never sleep. You're absolutely right. They enable a scale of human cognitive mimicry that has not been possible. So, for example, I might compare a couple of hundred faces a day, but I'm not going to be comparing a billion faces, right? So some of the big tests of face recognition algorithm performance, they're making comparisons between billions of different face pairs. So this is a question of scale where errors that are very small could compound because there's so many actions being performed. So I think computer scientists could question a little bit their own perception and cognition. And I think it would be easier for them to then accept that the default behavior of some of their own creations, a trained algorithm, for example, might not be optimal. And my colleague, I have a very good colleague that I work with at SAIC, his name is John Howard. He would call this, overcoming, he is a computer scientist, and he would call this overcoming Frankenstein bias. So this is a tendency to view your own creation as perfect. And I think if you realize that you yourself aren't perfect, then it's easier to do that and sort of let go. You're not a bad computer scientist because you trained a biased AI. It's just a fact of intelligence in general tends to be biased because the best example that we have is our own, and we are.
Ron, Kenett, any comments?
So, first of all, if you use a knife to cut a salad in France, they will kill you with the knife. You're supposed to cut it with your hands, right? So my elevator pitch is, we keep talking about data, but what we are really interested is in information. So we should move the discussion to the quality of information that we generate. And I have a book on that. And if you take an information perspective, your first step is to elicit the goal of your analysis. There is no way you can talk about the value of information if you don't have a goal set up, right? The same thing for goal 1, fantastic. For goal 2, completely useless. So that will force you to what I call a life cycle view. The process that Ron was talking about, it's a life cycle view from problem elicitation, which deals with unstructured issues. You don't start like the textbooks. You talk to people, they explain to you what they want, and this is contradictory. They will want this and that, and you know that both things cannot be obtained together. And you have to really find out what it is that they are really talking about. And then you have a goal. That goal is how you're going to set up your analytics, and that's how you're going to evaluate your end result. So I think the part of the answer is to move the discussion. People talk about data quality. I think they really mean information quality. They sort of mix up a little bit the terms. you start with numbers. We have numbers, but you have to go through the steps until you get some information. And we should have a properly developed methodology to help us through these steps. That's what I've tried to do in this information quality framework. And I'm just
cool
at the initial phase of that. I'm not saying this is ultimate, but I think statisticians should see their job as generating information quality. So now when I'm asked, what is your job? That's my answer. It used to be applying mathematical tools and statistical thinking. People didn't really know what I was talking about. When you say information, they can relate to it. When you say my job is to ensure information quality, they sort of indicate that, oh, that can be useful.
Cool. And we're getting at the top of the time. I mean, so one sentence or two at the most. What else would you propose to combat bias in AI? Ron Fricker, start with you. Yes.
I think I'm just going to go back to, I don't think it's more, I don't think it's new. I think it's more of testing on the output side. I think that's the key right there. It's care and testing.
Yevgeniy?
I think educating the customer about how your system works and how they could be successful at setting it up and how they could test it. Yep.
Yeah. And Ron Kenett, finally.
I'm going on the psychological perspective that Yevgeniy. I think it should be discussed. I think these things should be discussed, and people should take the time for these discussions. And if it is just discussed, no methods really, just the discussion, the awareness will come and people will ask questions, people will look for answers. It needs to be placed on the roadmap of the development of the AI and this discussion. I think it should be, and the education, if people come with some awareness of that, obviously it's going to make things easier. Yeah.
Good. Awesome. And I want to thank you, the panelists today, for a great panel. I've learned a lot, in particular in the statistics and statisticians, and what the statisticians do and how they compare to the work that computer scientists are doing with AI, ML, and NLP. So I really want to thank you. I hope the audience have a blast with this and they have learned as well, and as much as I learned today.
Thank you, Rod, for that interesting panel. Next, Laura Freeman, who's the director of the Hume Center's Intelligent Systems Lab, located in Arlington, Virginia. Her research leverages experimental methods for conducting research that brings together cyber physical systems, data science, artificial intelligence, and machine learning to address critical challenges in national security. She develops new methods for test and evaluation, focusing on emerging system technology. Please welcome Dr. Laura Freeman.
All right. Well, thank you, Brad, for the introduction. I'm looking forward to talking to you all today about bias in artificial intelligence. And I'll be creating kind of the motivation for the need for AI assurance, which is some of the work that we've been doing at Virginia Tech. So before I get started, I find a story is always nice to connect to. And this story actually played on NPR when I was driving back from Blacksburg, as we were actually kicking off some of our AI assurance working groups before COVID. And so you can see February 5th, 2020, back when things were normal. But as I was driving back to Arlington, I'm located in the Arlington part of Virginia Tech, this story came on the radio talking about how graduates of historically Black colleges may be paying more for the same loans, according to a watchdog group. And so what this watchdog group had done is they created a fake man, and they ran some tests posing as this 24-year-old individual making $50K a year. And they submitted applications with him attending different universities. So for example, NYU versus Howard. And what they found is when they got the approvals for the loans back, that he was offered a loan that would cost him $3,500 more at Howard and on a 30K loan. And so this is, there's examples galore out there about how algorithms leveraging data are translating these biases forward. And this is exactly the bias that we wouldn't want to see in any of our AI algorithms. What really caught my attention in this story, though, is that they had both perspectives, both the watchdog, and then they interviewed the CEO of the company, Upstart. When this company was founded to make lending more accessible widely. So the CEO was talking about how they compare on more than 1,000 different factors. As a statistician, bells are going off in my head of, okay, well, how do you, make sure that what the test group was trying to compare on is actually what was causing that difference. And he was emphasizing, credit shouldn't be biased in any unfair in any way. And he also noted that the company had tested for fairness and bias over millions of applicants. And so I found that a very interesting contrast, that you could find this single kind of illustrative case study that found bias in spite of this company having a commitment to not being biased and doing due diligence in their test process to try and ensure fairness. And I think this story resonated with me because, first of all, there's a lot of experimental protocol in there. How do you actually define what a bias is across what meaningful factors? Of course, our radar goes off when we're talking about HBCUs or minority serving institutions. We definitely want to make sure that there's not biases there. But what about biases based on what state you live? And how do you define the parameters that you care about bias over? And then how do you test your algorithms to make sure that they're going to be fair? And I think the final comments in this story provide some interesting context for us as we think about bias. First, they highlighted that this casting such a wide net for data introduces biases in new and different ways that potentially we haven't thought of before. And I'll show you an example of that in my comments today. And this push for better oversight. So I want to contrast that with some additional select national priorities in AI. So at the Hume Center, where I work at Virginia Tech, we're focused on national security. And in particular, my lab, the Intelligent Systems Lab, looks at artificial intelligence and the adoption of artificial intelligence into national security priorities. And so we've been reviewing these large national strategic initiatives from the Department of Energy, NIST, the artificial intelligence ethics for the intelligence community, the DoD. Lots of people at this point have now put out these national priorities. And in all of them, you're going to see terms like objective and accurate, and objective and equitable, robust, resilient, reliable. And so we're seeing this push from our leadership in the federal government in order for them to be able to adopt AI. They need these guarantees, these certifications. And so a few themes that I'm noticing as I do my work and develop our research portfolio is that the government is demanding that we move beyond predictive capability. It's not just how good your AI can be, it's how often it can be that good and across how many different factors, so demographics, different stakeholder groups, that it needs to work not just once, but kind of always. It needs to be better than a human. It needs to be better than the current capabilities that we have. We're also seeing this trend that, it's not just about the data, that scientific understanding really matters, and we want to incorporate that into our analyses. One of the things that we focus on a lot in the Hume Center is that this AI test evaluation, verification, and validation, and that's becoming a research priority. How do you know when your algorithm is good enough to be fielded? How do you know that it's unbiased? And the final theme that I'll highlight is test beds as an enabling mechanism. So to conduct this kind of research, it's not just about building the algorithm, which is hard and requires a lot of compute power in itself. It's about building the algorithm and then testing it under lots and lots of different contingencies. And so that's going to require enterprise resources, shared data that spans different use cases. And so I've highlighted a quote there from our National Artificial Intelligence R&D Strategic Plan that highlights the unique value of test beds. And I also, in this, over these couple of days, will have the director of our AI test bed from the Commonwealth Cyber Initiative talking. And so we've really taken that concept to heart, that we need test beds to fully understand how our algorithms are performing. And so my research, it really takes this broad vision in terms of what do we need for AI adoption. And we're calling it AI assurance. I say it's an evolving definition because I swear every time I give some version of this talk or about my research portfolio, it changes. But you can see here in the picture on the right-hand side of the screen, what we've tried to define is kind of broad classes, leveraging those national priorities, leveraging information that people are putting out about what trustworthy AI means, that we need to be able to quantify for AI algorithms. So they need to be not only fair and unbiased, but also reliable, explainable, secure, privacy preserving. And we think about the portfolio of assurance as the level of confidence that systems, and I'll emphasize the word systems there, that are using AI have that it will operate as intended, free of vulnerabilities or mishaps throughout the life cycle of that system. And this level of confidence comes not from any one use case or any one test, as we saw in kind of what the watchdog group looked at in the loan data, but it comes from the systematic activities that span all of those conditions that are of interest, all of the things that we need to be fair across around the life cycle of the system. So a foot stomp that it's not just the algorithm itself, it's the algorithm embedded in the system, and that performance should be characterized to be fair in relative to that deployed system, which the deployed system is going to have to operate in an environment that changes. So when we think about loans and loans for student education, that environment is constantly changing. The cost of higher education is changing. COVID has played. How do we think about what is going on with COVID in terms of loans and more classes moving online? I know in my neighborhood in particular, a lot of students actually ended up doing a few courses this year in community college as opposed to the more expensive four-year programs. And so all of that, those are variables in the landscape that impact how the algorithms that decision makers are using that need to be accounted for when we think about the assurance of our algorithms. So what are some specific research questions that we're thinking about for fair AI? So first of all, what is an adequate test program? When I heard that story on NPR, I immediately wanted to call up the CEO and, what were your millions of tests? How did you run them? How did you select them? Why did you know that those were the right tests? And those are the types of questions that we're going to have to ask of anyone that is providing an algorithm for decision making. How do you control for biases that are inherent to the data? So this is kind of a well understood phenomenon at this point, but if there's biases in the data that you're collecting and then you feed them directly into a machine learning algorithm that's going to learn from that data, those biases are preserved. So how do you control for them? How do you eliminate them? But even harder than that, how do you identify that these biases even exist? And then finally, a question I like to pose to myself is, what evidence do oversight organizations, the government, independent review boards, independent testing panels, what evidence do they need to enable the adoption and support that and write reports that say, yep, I certify that this algorithm is good to go? I think these are all very active and hard questions to answer. And to drive that point home, I'll give you just a quick example of a research project that we've recently completed, identifying biases based on training set data. So in this example, we're really driving home the point that a lot of the benchmark data sets that exist out there for machine learning have extreme imbalance in the input space. So for example, in our loan story, it's probably true that there's extreme imbalance in terms of the representation of HBCUs and MSIs. So how does that factor in that there are not as many of those universities as there are potentially other universities that they're considering in their data sets? So the challenge that we're looking is how do we quantify the impact of that imbalance if we're training on it, if we're testing on it? And so what my colleagues and I did actually is we used a mixture design, which is part of the experimental designs and the applied statistics research, to purposefully design our training sets and our testing sets so that we could quantify those biases. And so this is kind of a picture of what we did. So if you have just a bunch of different classes, X1, X2, X3, that make up your data set, what we're showing here is we're going to actually pick our training set so that it's disproportionately balanced towards X1 and X2 in this corner, or disproportionately balanced towards X1 and X3 in this corner. And our center point is, of course, we've got an equal mix across the different classes. And so in our loan example, these might be minority serving institutions in HBCUs versus community colleges versus a four-year college, just to be very broad generic. But that's what I mean when I say classes. Then what we did is we varied the proportion. That's what these X1 and X2 and X3 are here across those different class types, and came up with this experimental design. So this table is just that picture, basically in table form. And we looked at different breakouts of training and test sets. And based on the different breakouts, we calculated area under the curve for our ROC curves, or receiver operating characteristic curve, and measured how good we did. This is a little bit of an eye chart, but I wanted to show you kind of the breakout between training and test. So here we have our training data where we have all sorts of different designs of balanced versus unbalanced, and then we test all unbalanced data. Here we look at, again, the same, but we test on the consistent scenario, which see here you can see here's our training and our test looks exactly like our training. And then on the reverse scenario, we were trying to stress the algorithms as much as possible, where we trained in one proportion of data and then we tested on something completely different. So this is looking at, okay, well, so I train on the data that exists in my universe, which may be unbalanced, but when I'm selecting those kind of use cases, I'm thinking much more balanced. So how do I do when I have this unbalanced breakdown versus a more balanced test set? And here are the results that we found. First of all, so we were doing this actually on mouse embryonic stem cell data. So, that was the actual data set that we were using, and we were comparing between two different modeling types. But what I want to draw your attention to is here's our mean area under the curve. And if you look at these green dots on the top plot on the very far left, you'll see that for our balanced data set, those are all the 1/3, 1/3, 1/3, we do really well, whether we're using consistent or reverse coding. So balance in the training set is very important. But also something worth highlighting is that if we are looking at kind of the worst case scenario with the extreme data sets here, you can see that you can still do okay in the reverse coding if you get the right ingredients together. So this gives you some idea of quantifying how big that bias is. The other thing that I want to point out is that you can select algorithms. CNN is just convolutional neural network. XGBoost is another algorithm that's known to be more robust. And here we saw that it was not subject to the biases that were introduced based on balance, consistency, and reverse. So this is kind of the level of detail I think we need to get to when we think about quantifying biases in our data sets. And so I'll wrap up with kind of coming back to our motivating student loan story. What are the implications of the quick analyses I just showed you? Well, first, the discerning listener, or maybe the discerning policymaker or corporation that wants to adopt these types of technologies needs more information. They need to be asking questions about what was the proportion of the colleges and the data that the algorithms were trained on. How does that translate forward into expected biases? Can we control for those expected biases? How did the company select its test sets? Were they actually good enough that you believe they've done their due diligence in certifying the algorithms to be unbiased? What's the evidence there? Those kinds of questions need to be answered and need to be part of the discourse around the adoption of AI. I'll say that adoption of AI is focusing on bias today, but it's not just bias, it's model robustness, explainability, the security, All of those things are going to play a big role when we think about adopting AI into our everyday life, our decision-making processes, the critical work that our federal government does. Hopefully I showed you a quick little example of the exciting things that statistical methods and experimental design do in terms of providing a problem-solving approach to break down the issues of bias. But overall, these solutions are going to require interdisciplinary approaches and expertise. How do you know where to expect the biases? You need subject matter expertise. You need people that understand the processes. And a final thank you to all my collaborators who come from various disciplines. That they definitely make this research kind of more fun and more robust and fair, maybe. So thank you for your time. That's what I've got prepared for you today. And enjoy the rest of the workshop.
Thank you, Laura. Now it's my pleasure to introduce our final speaker today. Michael Beckley is a founder and CTO of Appian. Michael leads Appian's technology vision. He has served on multiple boards, including Appian's Board of Directors, the Industrial Advisory Board for the University of Virginia's Computer Science Department, and has served on the University of Maryland's Advisory Board in Computing. He also advises a variety of other groups, including 1843 Capital, CNAS, Appian Women, and the Appian Pride Affinity groups. Prior to founding Appian in 1999, he was a product manager and led industry analyst relations at MicroStrategy, Inc. Please welcome Michael Beckley.
Well, thank you, Brad, for that introduction. Really happy to be here with you all today to talk a little bit about artificial intelligence and the important topic of what do we do about bias in AI. At Appian, we come at this from a pretty unique perspective. We're a low-code platform. That means that we help the largest organizations in the world automate their digital processes. That's private companies, that's government regulators. If you think about Appian's customers, they are themselves some of the most highly regulated businesses in the world. They're banks, they're financial institutions that are responsible for, extending credit and loans, deciding whether or not you get a mortgage. They're healthcare firms, they're hospitals, healthcare providers deciding on what kind of treatment you're going to get. They're public sector agencies that are trying to determine your eligibility for benefits or whether or not you can get insurance. They're the insurance companies themselves who are deciding every day about what to do with your claims. And so these highly regulated entities have to approach artificial intelligence and automation technologies from a position of conservatism, to say the least. They have a legal and ethical responsibility to ensure that the technology they use is actually helping people and helping them accomplish their mission in a responsible way. And at Appian, we take that obligation very seriously. Appian has become a leader in digital process automation because we have this unique ability to orchestrate humans, RPA bots, and artificial intelligence algorithms and all of the company's resources into a single workflow. And so what we've done for the last 20 years is help companies think about not just the work they do, but how they can reimagine it, but also how that human technology connection will be reimagined to always ensure that the technology is accomplishing what you expect it will. Even great technology can go wrong when it's simply misapplied. And that possibility is legion with artificial intelligence, because when we delegate a decision to an AI algorithm, we can make that decision so much faster, but it's also potentially difficult to understand how that decision is being made, precisely because it's happening so quickly and because the decision model isn't necessarily going to be transparent. And it's hard in many cases to ask an AI, why did it decide to give you a loan, or why did it decide to reject an application? So at Appian, in our experience, we found that the first and most important thing when it comes to thinking about artificial intelligence is it really the right answer to the problem? And if it is the right answer, in what way is it? I think that when we look at the most common headline-grabbing mistakes that we've seen in the artificial intelligence community over the last 5 years, they frequently come down to teams that are rushing in to use a new technology without thinking through its implications or the nature of the problem they're addressing. So take one example, Compass. Compass was a sentencing algorithm that's been used in Florida and many other states, and it's been widely debated and quite frankly argued in court all the way up to the Supreme Court. Because what Compass tried to do was delegate the decision of deciding on whether or not someone was going to stay in jail, what kind of bail they would get, to an algorithm. And of course, the algorithm's creators would argue that that wasn't its original intention at all, that they were trying to provide advice. They were trying to provide more information so that people could make better decisions. But ultimately what happened was this idea that we could assess an individual became instead a tool to automate how we treated people. And so people would come before the courts, and this Compass algorithm would decide how dangerous it thought you were and what your chances of recidivism were, what were your chances of committing another crime. So this is an incredible, important decision. This is life or death, literally. You know, will you be able to go back to your regular life, or will you be, treated harshly and have your liberty denied to you? And a lot of that came down to what this recidivism score, this risk score was going to be calculated to be. And yet when we look at the team that created that AI model and we look at it from a clinical sense, what data did they use? That was not terribly complicated data. It was a pretty simple data set of past offenders and their demographics. And so it seems like a pretty logical place to look. If you just think about it, what's our history here? If we want to predict the future, we'll look at what kinds of people have gone to prison in the past or been arrested in the past, but not gone on to commit crimes, and which people have proven more likely to commit crimes again. And then when we look at the data model they used, it was relatively simple. They looked at a few key features, or we call them the attributes of the data. You know, what kinds of things we're looking at, where you live, what kind of job you have, how many crimes have you committed in the past, how many times you've been arrested. And the technical techniques they used, the type of technology they went into their AI algorithm itself was also not terribly sophisticated or complicated. There wasn't a lot of room for mistake in that. But instead of getting a simple answer, which is reliable and accurate, what happened was catastrophic. You saw African Americans who were not likely to commit crimes still getting scored twice as likely and twice as risky, or nearly twice as risky as their Caucasian counterparts, who themselves when the algorithm made a mistake, it would find it was twice as likely to cause a Caucasian to score as having a lower risk than their African American counterparts, even though they had a substantial history of criminal behavior. So that inability for the algorithm to make mistakes in an unbiased way was its own unique problem, on top of it just being a inaccurate algorithm. It was biased, horribly so, in terms of racial disparity. So we have to think to ourselves, how is that possible, and how do we make sure we build systems that don't fall prey to that? And the first thing we have to think about is, what is the subject area we're tackling? Is this an area in which there's already a history of problems and bias? And this is important because, well, if you looked at, say, sentencing guidelines and criminal justice, we know this is an incredibly controversial topic in society, and one fraught with its own very complicated and terrible history here in America, let alone in different places around the world. And so with this knowledge, when you go into this problem, if you're going to try to tackle it with artificial intelligence, which is its own controversial idea, you need to at least understand and appreciate that you're going to find biased data, you're going to find biased outcomes, you're going to find biased participants. You're going to have to control for these things if you're even going to make an attempt. And it's questionable whether or not you should make an attempt in this area unless you know exactly what you're doing. And so that knowledge of a problem set is really vital for anyone trying to embark on using artificial intelligence. Why are you doing it, and what context are you doing it? And then also, when you think about how the people who created this algorithm defended it, that it was supposed to be just used in an advisory role. We have to be realistic about tools. When tools eliminate work, we have to plan for how they'll be interpreted by humans who will not necessarily have been in the planning sessions, who will not have been in the decision to purchase that tool. They're just going to use what they have in front of them for the next decade, probably. And so we think about this as vital up front to think about what is the training, what are the people who are going to be using this system, and what's the likelihood for them to be able to misuse it? What are the systems in place in the overall solution to prevent misuse or misapplication of a technology and of an automation technology, whether it's an artificial intelligence algorithm or an AI bot, or even just a poorly programmed business rule. So that's the second thing. And then the third thing, of course, is how do we put this all together? What kind of expertise do we have, both in core data science algorithms? How good are you at understanding these tools, but also in the specific tools and techniques for overcoming bias? And so let me just like amplify this with another way. When you think about looking at bias, it's easy to understand how discriminatory policing practices in the past, African Americans being stopped at a much higher rate despite having a lower likelihood of there being any contraband found in their vehicle, right? So we know there's a history there, and we know that that's going to create a bad data set that is going to have its own bias if we try to train an AI algorithm on who to stop and who not to stop, if it's already based on bad decisions from the past, on human biases that have been programmed into the data set. So naive approaches to data science will then say, well, we won't look at the troubling columns of data. We'll just take out race. We won't consider that. And then suddenly we'll think that we have a fact-based approach, a non-subjective approach to training an AI algorithm. And of course, you haven't cleaned up your data. All you've done is mask the bias in it when you start ignoring columns of data that are real in it. So what happens is the algorithm will learn the same things it was going to learn before, the same biased decisions about who to stop, who not to stop, what risk score to assign, what risk score not to assign. And it will learn it based on what dimensions are left. So instead of race, it might substitute zip code or postal code. And essentially you get the same result, a biased AI algorithm in the end. And so with Appian and our approach to using artificial intelligence, we have first focused on domains which are not controversial, on domains like intelligent document processing, more accurate scanning of documents, more accurate reading of applications of any kind, and we have therefore created a situation where we're less likely to run into controversial problems to begin with. And the second thing is, when we look at the data sets, we're quite mindful of choosing data sets which have already been vetted academically for bias, where researchers have spent a lot of time looking at them and arguing over these different data sets. If you take a natural language processing tool and look at what was that algorithm trained on, what did it read to learn to read? Well, the reality is it's going to have learned to read whatever biases were in its data set. So if you train an algorithm on Google News, not to pick on Google, but if you just do that, and a lot of NLP algorithms do because it's such a great big data set, well, it's going to reflect the biases inherent in our news cycle. And those are well-known things. Like the news likes to say, if it bleeds, it reads, right? It's the old cliche. So it's not going to give you an accurate picture of the world. It's going to give you an accurate picture of what the news has decided to print, if you will. And so we're careful about what algorithms we choose and studying them ourselves and looking for identifying bias in them. And then third, we have to think about the teams themselves that are creating and working with the algorithms. If the team working on Compass had been more diverse itself, those people probably would have had a better chance of identifying the bias in the data, in the model, or in the results of their system long before it affected so many people's lives and became the subject of Supreme Court litigation. So that's another goal of ours, is to ensure that we have different voices, different backgrounds involved in the building of our software, so that we're getting a clearer picture of how our software is being used and its potential disparate impact. But like I said as well, being a platform that's devoted to low code, we're trying to make sure that business rules and algorithms like AI algorithms aren't buried so far down inside of lines of code that no one can see or observe or see what's happening with them. What's so special about low code is you build applications by drawing a model, like drawing a workflow diagram, rather than writing thousands or millions of lines of code. And this means that more people can be involved in auditing the process. More people can understand the end-to-end business process. More people can understand the decision to use an RPA bot or an AI algorithm to make a decision. And when it comes to the services that Appian provides, we provide you built-in AI services. We're very careful to choose domains where bias isn't a factor, or if there's a potential for bias, that it's been very carefully weeded out of the data sets that we use and reviewed by diverse teams. And so the end result is, while Appian low code allows you to avoid having to hire specialized programmers to build really important mission systems or business systems, so you don't need database programmers as much, you don't need mobile and iOS developers and Android developers to make sure your software works on your mobile phone. You don't need security experts in the same numbers because we provide the security expertise in the platform. It's our obligation to provide a platform as well that itself eliminates your need to have this army of well-trained data scientists who get it right every time. You know, you're getting the wisdom of crowds here, in that all of our clients who use an AI service from Appian are helping validate that it is unbiased, accurate, reliable, and robust in different situations. And so, you know, this is just another area where the opportunity with AI is so strong. The economic returns are so great when you can automate work and help people avoid having to do mundane, repetitive tasks, but instead have an AI help them. You know, that this technology is being adopted rapidly. And where we see it successful is frequently, you know, in these consumer services where they're non-controversial and the AI can help us, say, personalize our reading list, or suggest some related products we might want to buy in a market basket analysis to find related things that go with what we want or what other people have purchased, you know, as well. If you're, you know, the summer's coming up and maybe you're trying to open your pool, and if you're so lucky to have one, or maybe you're working on servicing the community pool, and you go to buy some chlorine, maybe it'll also recommend some other chemicals in a cleaning basket, and you know, new parts for your pump. Just that intelligence to understand the relationship of the things around us to make our life easier. You know, I think that's obviously why artificial intelligence is so compelling, and it has been, you know, for as long as science fiction writers have talked about it, since the term itself was coined. Artificial intelligence at Dartmouth College back in 1956, I believe, by Professor McCarthy, in a symposium where they got together, these academics, and thought about the future and where computer science and software could go. You know, that's really the dream of anyone who built a computer, was to help people do their work faster and better, to help us be more human, because we wouldn't have to be robots. We wouldn't have to act like robots. You know, the mundane work, the repetitive work can be done for us. And so that's still a very real possibility. But when the AI algorithm merely reflects our history, our troubled history, and our flawed humanity, that's where we get into trouble. You know, I think about some examples here where even consumer technology firms, you know, essentially unregulated firms, have gotten into trouble. And I think they're instructive for all of us. You know, Microsoft had a bot they created for Twitter about 5 years ago, Tia, and so they gave it a cute persona. It was supposed to be friendly. It was going to engage you in small talk, and you know, the problem was the bot was really just a glorified parrot, and so whatever you said to the bot, it would learn. Whatever you said to this AI, this algorithm, it would learn and essentially parrot back. The end result was predictable. Within 24 hours, Microsoft's happy, friendly Twitter persona had become racist, sexist, misogynist, you know, just xenophobic, all the things that trolls on Twitter and people who thought they were having some fun were able to do, and they had to shut it down. You know, early artificial intelligence efforts were really not that different. One of the most famous was a program called Eliza, which pretended to be a therapist, and in the guise of engaging you in a conversation. And it really just would ask you, how are you feeling? And whatever you said, it would say, well, how do you feel about that subject? And so this is the danger. One of the dangers of today's AI systems is that if we don't think carefully about who is training the AI and what they're training them, then we can make the mistakes of the past. And if we don't think carefully about how we use these AIs, then we can find ourselves in trouble. And I think one of the easiest answers to help you have a more likelihood of, higher likelihood of success is to work with, a platform company, one that is experienced at working with AI, experienced at handling a lot of the data science problems for you, and helping you structure your work such that it is easier for humans to review where in a workflow is the AI going to be applied, and where the AI can be used for its strengths, but not misapplied in ways that will undermine its reliability or resilience or robustness for different types of use cases. It's so important to orchestrate AI algorithms as just one another worker in an orchestration of digital workers and humans. And to understand that means that we can actually get real benefit from from AI today without getting ourselves into trouble with bias. So if we just take traditional OCR technology, it would scan a document for us, but it would require a tremendous amount of setup every time there's a new document type, every time a new vendor gets signed on and they have their own invoice and they have their own format. They put their company name on the top, or they put it in a cute label on the side on the left margin, or wherever happens, they put their invoice number in the upper right or the lower left, or they use invoice number and they abbreviate it, or they don't. Each of those document types used to require extensive training and setup. And now we can use artificial intelligence to read that document and discover what we want. And whether it gets it completely right or not isn't a question of bias. It's simply a question of, is this algorithm the best fit for the problem? And then if it isn't getting straight through processing, if it isn't 100% accurate, and it, for now it won't be, we can automatically route that to a human and still have done 99% of that document reading accurately for the human, and show that person which field isn't accurately represented and which field is. And so we've taken a tremendous amount of manual labor and reduced it down to a small fraction of what it used to be. And we've done it safely. We've done it in a way in which we know the outcome of the decision about whether or not someone is going to get a loan or someone is going to get the right medical procedure isn't entirely reliant on an AI algorithm. Quite the opposite. It's giving humans the information they need accurately to make the right decision, and giving us a workflow which allows us to monitor the outcomes of our decisions so that we can compare them against what we'd expect for different demographics and populations. And that's really the last important thing to think about with bias, is we have to ensure that we're not taking anything for granted, that we have good metrics so that we can hold ourselves accountable and report on the outputs and make sure that we're getting the results we expect out of artificial intelligence. So I just want to say thank you again for listening and for inviting me to talk today about AI and bias, and really thank you to NVTC for hosting this forum. I look forward to your questions.
Thank you, Michael. We're now going to take questions from the audience. We have several of our speakers on today to answer them. So let's get started.